In this video, we're going to start section 7.3 on joint distributions. The goal of the section is to define the joint probability mass function or joint probability density function of two jointly distributed random variables, and to use these functions to calculate the probability of events. When considering only one random variable x, we use a function of a single variable, either a probability mass function, if x is discrete, or a probability density function if x is continuous. And we use these functions to calculate the probabilities of events involving x. In an analogous way, when we consider two random variables x and y simultaneously, we can use a function of two variables to calculate probabilities of events involving both x and y. When we consider two random variables simultaneously, we call them jointly distributed random variables, or just joint random variables. Subsection 7.3.1, joint discrete random variables. Definition 7.3.1, let x and y be discrete random variables. The function p of xy, right, a function of two variables, is a joint probability mass function for x and y if p of xy is greater than or equal to 0 for every xy value. If you sum up over all x and all y the p of xy values, well, you're going to get 1, because this is what we're thinking about as probabilities. Probabilities have to be non-negative, and total probability has to be 1. And the probability p of xy is the probability that x is equal to little x and y is equal to little y. Secondly, if A is any set containing xy pairs, then the probability that the random pair capital X capital Y lies in A, which means that x and y pairs take on values of little x little y that lie within A. In other words, the probability that xy is in A, that is calculated by summing up over all the x, y in A, double sum, because we have x and y values of those values. So you take all of the x and y values in this set A and you sum up their probability values, and that's the probability. Now, we're going to look at an example a little bit down here of what these set A's can be consisting of. Before we do, though, another way of writing this and that we have up here is as an intersection. So the probability that x is little x intersect, right, that is red and, intersect y is equal to little y. Although most commonly, honestly, the way that we write it is just with a comma. The probability that x is little x, comma, which is red and, y is equal to little y. So then what about these sets A? What does that mean? Well, they can be described in all sorts of ways. For example, A could be the set of all xy such that x plus y equals 5. Or A could be the set of all xy such that y is greater than 0 or x is less than y. There's all sorts of ways of describing sets A that contain xy pairs. In the next video, we'll work on an example using a joint probability mass function and see how some probabilities of events are calculated using it.